All right, guys, let's go ahead and get started. Few announcements. First of all, your homework number 8 is due on Sunday, and that includes an external rate of return problem. We're going to also go over bonds today, and the bonds are going to be included on the next assignment. So keep that in mind. The material that we're going to be covering does include some things that'll be on the assignment due Sunday, and then also the assignment number 9 that you'll be getting later. So we're going to be continuing our discussion of rate of returns. And let's just review, first of all, what is the internal rate of return, because that's what we discussed last time. The internal rate of return is the type of assumption where you're deciding that the cash flows that are generated from a project can be reinvested in that same project or an identical one that generates the same return. And so an example of the internal rate of return would be a savings account, because a bank is going to allow you to keep the interest in the savings account, and then they'll compound that interest at the same rate that it was originally generated. And so that's a great example of something that can be reinvested at the same interest rate. But not all projects are like that, and so there are many occasions where the cash inflow that you get, the receipts from your original investment, there's many cases where that can't be reinvested back into the project. And so you have to find someplace else to put that money. And so an example, and think about if you invested in art and you purchased a rare painting, and people are doing that nowadays. They buy some art and hoping that the price of it will go up in the future as more people appreciate art, and as the population grows and the number of famous paintings stays the same, then the value goes up. So if you buy a rare painting and then you sell it, and so now you have some profit, let's assume that you buy low, sell high, and you get to keep the difference, the profits there. You can't put that profits into the same painting because someone else owns it. And so you're going to have to find a different investment for those profits, and it's not going to generate the same return as the first investment did. And so the external rate of return actually is probably the case more often than the internal rate of return. There's many more instances where your business is going to be generating cash, and maybe some of it can be reinvested into the business, but in many cases you have to find someplace new to put the returns. So that's why it's important for us to learn some method to deal with the external rate of return. And remember, the whole purpose for these rates of return is to compare it to the MAR. It's a way of saying yes or no to one particular project, but it's not supposed to be used to compare rates of return against from one project to another. We use other methods of analysis to decide against multiple alternatives. Okay, so here's the method for external rate of return. It's easy to get wrong, so I really hope that you'll pay attention while we do the method, because this is an important thing. There's two different interest rates when we're doing the external rate of return. Remember that we said that you're not actually going to be able to reinvest your earnings at the same rate that they were originally generated. And so here in bold, it's called the external reinvestment rate. And the external reinvestment rate is how much you can earn with those profits that are generated. So let's say, for example, that you had a savings account, and that savings account didn't let you keep the interest in that same account. Let's say that they forced you to take out your interest rather than putting it back into the account. The external reinvestment rate would be the interest rate that you are putting those returns into. So if you had a second account and you took the interest from the original account and put it into the second account, this epsilon, the external reinvestment rate, is the interest for that secondary account. And it's where you put the extra cash that's generated. So with that rate, the method for the external rate of return is that you take the outflows from your cash flow diagram and you discount them to times 0 at epsilon. Now, I'll show you a cash flow diagram here in just a moment that summarizes the method. So you take all of the outflow or payments to the present, you take all of the inflows from your cash flow diagram to the future, and you move it to the future at the same external reinvestment rate. And then the external rate of return, which is a different interest rate, is the unknown rate you have to solve for that makes the two equal, that makes the outflows at the present and the inflows in the future equal to one another. Here is the formula that just sort of conceptually summarizes what you're doing in that operation. It says you should take all of the outflows, or it's abbreviated here as expenses. You take all of the expenses for the whole project to the present. So each one of them that occurs in the future, move it to the present, and if there's something already in the present, keep it at the present. But the things that are in the present, you discount it, the expenses that are in the future, discount it to the present at epsilon, which is the external reinvestment rate. And then you take all of the things that are inflows, and you take them from the present into the future. So you put them all at the end of the cash flow diagram if they're inflows. And then the relationship that's this bracket here, F/P, you're trying to solve for the interest rate, unknown interest rate I prime, which is the external rate of return, that establishes equivalence between the revenues and expenses. Okay, so here's a cash flow diagram that summarizes the procedure. And take a look at this. It's saying start with a normal cash flow diagram. You move all of the outflows to the present, all of the inflows to the future. And so that's what this second graph is showing. This is after you've moved everything to either the present or the future. And if it's an outflow, it goes to the present. If it's an inflow, meaning revenue, it goes to the future. And then you're using epsilon, which is the external reinvestment rate, for that discounting and compounding. Yes, this outflow right here, you moved it to the present. And all of the lines on top, all of these inflows, you move to the future. And you do it at epsilon, the external reinvestment rate. And that is the interest rate that you can earn on the earnings. And so it's, you take all of your money and you put it in another account that pays epsilon. That's what you're doing the discounting and compounding at. Okay, so that's the first and second step. And then the third step, down here in the bottom, what you're doing is you're trying to find out what interest rate makes these two equal. And so there's two ways to do it. Either you have to take the money at the present and compound it to the future and find out what interest rate will make them have the same magnitude, or you take the amount in the future and you discount it to the present at the interest rate I prime that makes them equal in magnitude. Okay. So we're going to get a try of the external rate of return. You have in-class exercise number 1 there in front of you. And I've provided a cash flow. It looks like in year 0, we invest $25,000. And then we have 2 years of revenue. And then in year 3, there's another year of investment. And after that, there's 4 years of revenue. So step 1, you're going to discount all of the outflows to the present. Step 2, you're going to compound all of the revenues to the future, meaning to year 7. And then step 3 will be make the future worth and the present worth equal by either compounding one of them to the future, compounding the present to the future, or discounting the future worth to the present at some unknown I prime, the external rate of return that you're going to be solving for. On the handout, I give you a template for the spreadsheet. You don't have to follow the same format. You know, you can do the calculations an infinite number of ways, but this is maybe one way just to set things up to begin to get organized. So here is the template for Excel. All right, many of you are getting already to the point where you're calculating this. This part is easy. You've done this sort of thing before where you are finding the present worth of outflows using the external reinvestment rate and the future worth of the inflows at the external reinvestment rate. So this is the amounts, okay? So that part is something you've already done before. In the spaces below that, what I'm saying is put in some guess for the external rate of return. Let's say 0.01 as a starting guess. Okay, if you're trying to make this future amount equal to the present value, in this cell what I'm saying is let's find the present value at this external rate of return, and we know it's 7 years apart, so I'm going to put in 7 for NPER. We'll skip over the payment field, and the future value is this. This is the future value that we're trying to get equal, and I'll do negative of that since it always changes the sign in the PV function. So if you are moving this $37,000 7 years into the past at 1%, then the value of that is 34. So that's not 25. What about 2%? We're getting closer. What about 3%? And so on. So I hope that you get the idea that what we're trying to do is we're trying to get the value of this future amount equal to the value of all the cash flow that's in the present. So making these two equal, and you're changing this interest rate to do it. You're not changing the external reinvestment rate. The external reinvestment rate is fixed. What we are trying to solve is the external rate of return. All right. All right, so here we have two amounts, and we have to make them equal. Either we have to move what's in the present to the future, or we move what's in the future back to the present. I've set it up so we're taking the future amount to the present. That's what this description means. And so I will do the goal seek, which is data, what if analysis, goal seek. And our goal is that we want this amount to be equal to 25, 928, 60. And what we give it permission to change is the amount in the external rate of return. And it takes just a moment for it to show it's 5.22%. Is that what everybody got? All right, great. So let's just review. One thing that's a little bit confusing is that there's two different things that have the same abbreviation. Okay, what's confusing, I find, sometimes students struggle with this acronym ERR. Why would that be confusing? The acronym itself. Because we have both the external reinvestment rate. So that phrase, external reinvestment rate, starts with ERR, but also a different phrase, external rate of return, also kind of has the same acronym if you were to abbreviate it. On the exams, I find that most of the time when students get the external rate of return problem wrong, it's because they've confused these two different things. So rather than using that abbreviation, I generally don't, but I'm bringing it up now just because I think I saw a handful of people abbreviating it as ERR. The variables are epsilon for external reinvestment rate and I prime for external rate of return. Who can explain to me what is the external reinvestment rate? Anybody know what that is? No? You're thinking internal rate of return. Okay. The external reinvestment rate. So if you have an investment like a business or any kind of investment that's generating money, the external reinvestment rate is where you put your money if you can't put it back into the original project. And the external rate of return, what we just solved for, it takes two things into account. It's kind of like an average rate of return because it takes into account both the external reinvestment rate and also it takes into account the rate at which cash is generated, so the cash flow diagram itself. So it's taking into account the project's yield and also the external rate of return. All right. Yes? Yeah, I'm running out of ways to explain it. The same thing. Let me dim the lights. Okay, so I'll explain it graphically and then I'll explain it in terms of a company. So graphically, the external reinvestment rate was the interest rate that we used to move all of the cash inflows to the future and all the cash outflows to the present. So that is, you can see epsilon, the external reinvestment rate, where the rate of return was the interest rate that makes these two equal. So if we move the future to the present, then it was the one that makes those two equal. Now in terms of an actual company, let's say that you have a company like we talked about if you buy a truck in one of our previous in-class exercise. So you buy a truck and you have it for a few years and it's generating cash. So it would look something like this. You buy a truck and you're getting revenue from it. Maybe one of the years you have a lot of mechanical breakdowns and so there is some maintenance that you have to do. Okay, now in an instance like this, once you buy the truck, all of the revenue that you get, you can't buy the truck again because you already own the truck. And so you can't reinvest your earnings back into the original item. And so you have to put those earnings somewhere else. The external reinvestment rate is where you put this money until the end of the project. The project in this case, I've just drawn a little cash flow diagram on the board. It looks like this is 4 years. So when you're analyzing a project, you're doing it in a 4-year period for this instance. And so at the end of 4 years, you ask yourself the question, well, where was I putting this money that was being generated? If you want to know the overall rate of return for this entire scheme, you have to know not only when is the money coming and how much money is coming, but also where do you put that money during the time that the project is going? Do you put it back into the project or do you put it somewhere else? And so to find the external rate of return, you're taking into account where you put this money that's generated until the project is over. All right, now we're going to be talking about bonds. And we've discussed bonds previously, but today we're going to be able to calculate what is the value of a bond based on the periodic payments and the amount that is due at the end of the bond period. Companies use bonds to raise money. And strictly speaking, the definition that's shown here is it's an interest-bearing certificate. Do you have a question in the back? Please don't talk when I'm talking. It makes it very difficult to concentrate when there are separate conversations in the back of the classroom. All right? Thank you. So the analysis that we're going to go through today tells you how much you should pay for a bond if you want a certain yield on the investment. And here's some terminology that you're going to have to be familiar with in order to do the calculations that have to do with bonds. First of all, bonds have a face value, and the abbreviation we're giving here is Z. And quite commonly, bonds will be sold for 100. It could be, if it's denominated in dollars, $100 for one bond. If it's denominated in dirhams, it would be 100 dirhams. You know, 100 is a typical price for a bond, and so that's the face value of the bond. It'll say actually on the certificate what the face value of the bond is. Sometimes bonds have a different redemption price than they do for the face price. And so an example of that in the United States, there's something called a savings bond. And sometimes if you're like a really boring uncle and you want to give your nephew a present, you know, like a fun uncle would give their nephew toys, right? Maybe a fun uncle would take their nephew to the water slide, you know, like Wild Wadi. A boring uncle will give their nephew like a savings bond because you're supposed to use it for college in 20 years. And so, you know, a 5-year-old kid can't get excited about a piece of paper. But a savings bond, the way it works is that you pay $25 and then in 20 years you give it to the government and they'll give you $50. And so it doubles your money after 20 years. So that's a savings bond. So in that case, in the case of the savings bond, the face value and the redemption price are different. But that's the exception rather than the rule. Most of the time, the face value and the redemption price are the same. But there are some bonds where they'd be different. In the case of the savings bond, the reason why they have different face price and redemption prices, they don't want to have to continually pay interest on those little bonds over and over every period. And so they build all of the interest into the disposal price. But more commonly, if you're going to buy a bond from a company or from a government, then you get interest periodically. It may be every quarter or every 6 months or maybe just once per year. But R is the rate that they're paying the interest. And then N is how many periods there are before redemption. And some bonds are issued for a period of 10 years, some maybe 20 or 30 years. It just varies, and N is the N value. It doesn't stand for years, it stands for periods. And so if it's a bond that pays quarterly interest, that means there'd be 4 periods per year. And so if it was a 10-year quarterly interest, then N would be 40. So you have to keep in mind not only the number of years, but also how many payments per year. Now, I is a different interest rate. I is the yield rate. The company is paying interest and that's fixed. But if you want to make a different interest rate than what the company is paying, then you have to either pay more or less for the bond than the face value, and then that affects the yield. And you'll get a sense for that when we do today's in-class exercise. Here is a screen grab that I got from a trading account that was offering a variety of different bonds. You can see that these are, let's see, we've got one company that's called Bottling Group LLC. I think they probably make soft drinks. You can see that they have an industry rating of AA3, which is pretty high. Here they're offering a 5% coupon, and that would be the face, the interest rate that's on the bond itself. But the price for it is 103 instead of 100. So what that means is that you're having to pay more than 100 to get something that has a face interest rate of 5%. And taking into account both that coupon rate and the price, you get something here that's called the yield to maturity. And that would be the yield that we're talking about in the previous formulas. Okay, so here's the equation. And you'll see that there's table lookup factors that go into this. The table lookup factors are applied to the redemption price and the amount of the earnings. So the value of a bond depends on 2 things. There's 2 components to the value of a bond. Let me write that on the screen here, on the whiteboard. Value of the bond comes partly from the value of redemption, and also the value of interest payments. What do I mean by redemption? The value of redemption means what? When you get your original investment back. Yes. Let's consider what would the cash flow diagram of a bond payment look like. So if we bought a bond for 100, that's a line down in year 0, and then we get all of these interest payments over time, and then at the end of the bond, you get your 100 back. And so what we're trying to find out is how much is this bond worth in today's terms? You know, how much should we pay for it? What's the value of all of these interest payments, and then the redemption value of the bond itself? So this looks, I mean, when we're talking about bonds, it maybe seems complicated and intimidating, but as soon as you draw the cash flow diagram, you suddenly see there's nothing that complicated about this. The bond value has two components. It's the value of the interest and the value of the return of the principal, the redemption. And that's what this formula is showing. It's showing the value in today's dollars, V sub n, is this first term is you take the future amount of the redemption price to the present, so P/F, and you discount that future value at the yield rate that you want to achieve, I. And then R times Z, that's the value of these periodic payments. And so that's the annual series. And so you're doing a P/A. You're taking the annual series to the present at the interest rate of the yield that you want to achieve for however many years n that there is. All right, so let's do that. I've described a bond on your in-class exercise paper. It's a 10-year bond that pays 6% per year, semi-annually is how it's paid. So you need to keep in mind the difference between the interest rate per year and the interest rate per period. Those aren't the same. The face value is $1,000, and that's also its redemption value. So we want to find out, the company is paying 6%, but we're only satisfied with 8%. So if we want to make 8% yield, then how much should we pay for the bond? If you paid $1,000, then you'd get 6%. So you want to achieve more than 6%. You want to make 8%. So just as a guess, how many people think that you should pay more than $1,000 if you want to make 8% interest? How many people think you should pay at the beginning less than $1,000 to make 8% interest? Nobody? All right, well, let's do the calculations and see. You've got the formula. You can fill in the blanks and solve for V sub n. All right, so on this one, here are the values that you should fill in. N equals 20 because there's 10 years, but the interest is being paid twice per year. So N equals 20. R, the bond rate per period, the rate is 6% per year, but remember our period is half of a year. So you only get 3% during that half year. So that's why R is 0.03. And the same logic applies for the yield rate. We want to achieve a yield rate of 8% per year, but per period that's 4% per period. And it says here in the problem statement that the redemption and the face value are $1,000. So you pay $1,000 to buy it, and you receive $1,000 at the end. So here are the calculations, and it shows the two components of the overall value. We take the $1,000 in the future to the present using this expression, and then we find the value of the periodic earnings discounted to the present, and we do the discounting at the yield rate that we want to achieve. That's why I've used the 0.04 in the lookup factors. But the company itself is only paying 3%, but what we're saying is that we discounted at the 4% per period that we want to achieve. So it turns out that if you want a higher yield than the face interest rate on the bond, you should pay less than the face price. So you should only pay $864 in year 0 to buy that bond if you want to receive an overall 8% return. on the bond. So don't worry, you'll have plenty of practice on the next homework assignment that you're going to get, so that you'll be able to interpret those, because sometimes it's not the calculations that can make it challenging, but interpreting the problem statement. So it's always good to get extra practice on that. Let's conclude with a quick look at the announcements for this time. What you need to keep in mind is that you have a homework assignment due on Sunday, and I will see you then. I hope you have a great weekend. Class on Sunday will be back in our normal location.